Hey class, in today's lesson we're going to talk about normal distributions, which is found in section 11-9 in your book. Our objective is to use a normal distribution. So a little vocabulary. It says a discrete probability distribution has a finite number of possible events or values, such as a binomial distribution. The events for a continuous probability distribution can be any value in an interval of real numbers. If a discrete set is large, the distribution of its discrete values approximates a continuous distribution. So a normal distribution has data that vary randomly from the mean. The graph of a normal distribution is called a normal curve, and a lot of times we hear it called a normal bell curve. So numbers that deviate from the mean within one standard deviation are 34% on one side, 34% on the other side. So when you add them together, anything that falls within one standard deviation is considered 68% of all the data. And then within two is 95% or 13.5 on each side. And then 99.7%, almost pretty much all of it. So a lot of times we like to say that they fall within 3 standard deviations fully. And also a normal distribution has a symmetric bell-shaped curve centered around the mean. All right, so skewness. So it says sometimes an extraordinary factor affects data that would otherwise be normally distributed, such as an outlier. In such a case, the data set could have a distribution that is skewed as an asymmetric curve where on one end one end stretches out further than the other end. So this first graph at the bottom, we see that it is positively skewed, and so that's skewed to the left. Then we have the normal bell curve, and then we have information that's skewed to the right, which makes it negatively skewed. We won't talk too much about the other skewness or the other skewed bell curves or distribution. We will mostly just talk about the normally distributed information. So in example 1, we're going to analyze a bar graph. It says the bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean, which is 115 kilograms. Approximately what percent of female brown bears weigh between 100 and 129 kilograms? So if we look at that information, 100 to 109 is this box here. So we're going to say that this here up until 129, which 120 to 129 is about here. Okay, so basically based off of what we have, what we should do is we should approximate those percentages. So for this box, this first box, from 100 to 109, that bar is going to be 23, and we use this section here to be able to see that information. So again, this is about, because it's not right at 25, so we're going to say that that's about 23. And then this line here, the center box from 110 to 119, is a little over 40, but not quite 45, so we're going to call this 42. And again, the box on the other side we're going to say is 23 again. So when you add 23, 42, and 23, you will get 88. So we would say 88% of the female brown bears are between 100 and 129 kilograms. Okay. All right, let's take a look at the next example. All right, so then in try 2, it says approximately what percent of female brown bears found in problem 1 weigh less than 120 kilograms. And without me going back to the previous screen, just to give you the bars of those that were less than 120, it's easier to say those that are greater than 120, because if it's less than, we're talking about this bell curve, right? And I shouldn't have gone back up like that, but about here, okay? And if we got to 120, we should really say 100 minus those that are greater, right? So those that are greater actually than 120 would be, this first bar is about, and you can go back or check in your book to verify, but the first bar greater than 120 is about 23. The next bar is 5, and the next bar after that is about 1. So 23 plus 5 plus 1 is going to give us 29, and so what we would do, because that's greater than 120, that's not what we want. So 100% minus the 29% is going to give us 71%. So 71% of those brown bears are less than 120 kilograms. And then the last question says the standard deviation in the weights of female brown bears is about 10 kilograms. So approximately what percent of female brown bears have weights that are within 1.5 standard deviations of the mean? So if we have, remembering that they said that the mean was 115 kilograms, right? And if we wanted to approximate the percent of female brown bears that were within 1.5 standard deviations, and we know that the standard deviation is 10, we're really now adding. All right, so really what we would do is we would say X bar plus 1.5 sigma, and then we'd have X bar minus 1.5 sigma. So sigma, remember, is 10. This is 10. So we say 1.5 times 10 is going to give us 15, and we're going to add that to 115. So that would be 115 plus 15 would be 130 kilograms. So that would be the upper end of what we're looking for. And then 1.5 times 2, again, that's not 1.5 times 2, that's 1.5 times 10, sorry, is 15. So we're going to say 115 minus that 15, and that gives us 100 kilograms. So we're looking for the bears that fall between 100 and 100 kilograms. And the bears that fall between 100 and 130 kilograms, I apologize. Let's see, once again, we get just about the exact same answer that we got the first time, because those three bars, that 100 to 109 is 23, that 110 to 119 bar is about 42, and then that 120 up to 129, you might as well say is about 130. That again is 23. So that would give you as an overall percentage 88%, again, of those female brown bears that fall within 1.5 standard deviations. So in other words, we just answered the same question twice. All right, so in example 2, it says for a population of male European eels, the mean body length and one positive and negative standard deviation is shown below. Sketch a normal curve showing the eel length at 1, 2, and 3 standard deviations from the mean. All right, so honestly, this isn't very difficult at all. All we're doing is putting this information on a bell curve. So if we have a bell curve, or we have a number line first, the mean body length is 15.7. So let's go ahead and first sketch this out and say that the mean is 15.7. So X bar equals 15.7. And so within one standard deviation, they've already shown us what that is, and within one standard deviation we get 18.5. So about here and here we get 18.5. For the first standard deviation, when it's positive, and when it's negative we get 12.9. Well, that's as far as the information that they give us about the first standard deviation, but it doesn't help us find, or actually it does help us find the second and the third, because as long as we have the find and we have one standard deviation, we can figure out how much each standard deviation is. So to be able to figure that out, it doesn't matter which one you want to choose. I'm going to choose the positive standard deviation. I'm going to say 18.5 minus 15.7. So if I throw that into a calculator, 18.5 minus 15.7, we'll get 2.8. So each standard deviation is going to be 2.8. So to find the second and the third, we'll just keep adding 2.8 to 18.5. So 18.5 plus 2.8 is going to give us 21.3. So that's for the second standard deviation. So 21.3. Mine should look, you guys should look a lot neater than mine. I'm just out of space. And then again, 21.3 plus 2.8. Again, that would be 24.1. Now we just go the opposite direction for when we are finding the other side of the bell curve. So 12.9 was the left side. Okay, that's the first standard deviation on the left. So we're going to take 12.9 minus 2.8. It's going to give us 10.1. So 10.1. And if we subtract 2.8 again, we're going to get 7.3. And that's it. Let's try the next one. It says for a population of female European eels, the mean body length is 21.1 inches. The standard deviation is 4.7 inches. Sketch the normal curve showing eel lengths at 1, 2, and 3 standard deviations from the mean. So again, here's our number line. I have a lot more space this time. Bell curve. Here's the mean. The mean is 21.1. They tell us that the first standard deviation, second and third, -1, -2, -3. But anyways, they tell us that the first standard, or that the standard deviations are 4.7. So in this case, this time they're actually saying, hey, you figure out what the standard deviations are going to be. So going on the positive end, I'm going to take 21.1 and add 4.7, and I will get 25.8. I'm going to keep adding. Plus 4.7, I'm going to get 30.5. Again, plus 4.7, and I'm going to get 35.2. All right, go the opposite way. 21.1 minus 4.7. It's going to give us 16.4. Again, subtract 4.7, and that's going to give us 11.7. Subtract one more time with 4.7, and we're going to get just 7 this time. And that's all we have to do. All right, so now in example 3, we're analyzing a normal distribution. So it says the heights of adult American males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5. What percent of adult American males are between 67 inches and 74.5 inches tall? So now what we're doing is basically using what we know about bell curves and their percentages along with standard deviation. So what we're going to do is we're going to create a bell curve. That's a bad bell curve, but just go with it. All right, our X bar or our mean is 69.5. And we need to find where 67 and 74.5 are going to fall. Okay, so remember within one standard deviation, let's see, 69.5 plus 2.5 is going to give us 72 on the upper end. And if I say 69.5 minus 2.5, I'm going to get 67. So we're getting close. So at least we have the 67 part. All right, so within 2 standard deviations and then within 3. I'm just going to find all of them so I can show you something. So 72, I'm going back on the upper end. 72 plus 2.5 is going to give us 74.5. And 74.5 plus 2.5 is going to give us 77. On the lower end, 67 minus 2.5 is 64.5. And minus another 2.5, we're going to get 62. Now, if you remember on that previous screen, I told you within one quartile, or excuse me, not quartiles, that's a totally different lesson. Within the first standard deviation, it is 68%, or in other words, this is 34% and this is 34%. And then the next set within 2 standard deviations, that's going to encompass 95% total. If I already have 68, 95 minus 68 leaves you with 27% that you have to split between 2 sides. So that's going to give you 13.5 here and 13.5 here. Now, if that's supposed to be 95%, then what's left over to get to 100%, or was as close to 100% as we can, would be about 5%. So we're just going to go ahead and round up and say this is supposed to be about 2.5 and this is supposed to be about 2.5. All right, so going back to the question, it says what percent of adult American males are between 67 and 74.5? So that means anyone from 67 to 74.5. So from this line down to this line, so that includes 34, 34, and 13.5. If we add those percentages, that's going to be 68 plus 13.5. That's going to be about 81.5% of adult American males are between 67 inches tall and 64.5 inches tall. Okay, let's do the try. Well, actually, it's not the try. We have to do one more. So it says, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? All right, so this isn't very difficult, but we're still using the same information from the last table. So taller or greater than 72 inches would fall within the greater side of 1 standard deviation. So on the right hand side of the bell curve, those numbers that were greater than, I'm just going to do a sketch real quick. those numbers that were greater than 72, we had about 13.5% left here, and then we still had that 2.5, or your book is going to say 2.35%. So as a percentage, what we're going to get is, let's see, 13.5 plus 2.5. I'm going to say that's about 16%. Okay, so if we have 16%, and then we need to go ahead and multiply that by the 2,000 people. So 2,000 people times 0.16 now, right? Because this is a decimal, so we need to change it to a percentage, so we got to change to a decimal. We're going to get about 320 adult American males over 6 feet tall. All right, let's try the next one. So in try 3, it says the scores on the Algebra 2 final are approximately normally distributed with a mean of 150 and a standard deviation of 15. What percentage of the students who took the test scored above 180? So here we go. Let's do this bell curve. We know 150 is in the middle. They tell us the standard deviation is 15. They're already talking about the upper end, so we're just going to do the upper end. So actually, let's go ahead and do both ends because we're going to have to do them anyway. So this is first, second, third, first, second, third. Okay, if it's within 15, I'm going up 165, 180, and then what is that, 195? On the back end of that, 150 minus 15 is 135. Subtract another 15, that's 120. Subtract another 15, that's 105. All right, so those that fall, and again, let's just be reminded, this is 35, 35, 13.5, 13.5, and these are about 2.5. It's really less than that, but we're just approximating so that we can say within 3 standard deviations it's 100%. Okay, so the percentage of those that scored above 180, that's going to be about 2.5%. Because greater than 180 would be that 2.5% there. And then it says, if 250 students took the final exam, approximately how many scored above 135? So that would now include these data. So if we add 35 plus 35 plus 13.5 plus 2.5, we're going to get 86% multiplied by 250. Well, really what that means is 250 times 0.86. And that's going to be about 215 students that scored above 135. All right, guys, that's it. Remember, if you have any questions, please be sure to come see me for tutoring.